Hello, hi everyone. Good evening to all. Today, this is Tushar from Biotechnica. I welcome you all to this session of General Aptitude. Please share this link with your friends so that they can also learn and enjoy the concepts of mensuration. So today, good evening, Shubhra. Just confirm that the audio is clear. Just confirm that the audio is clear. So today we'll be discussing about mensuration, and it's a very important and interesting topic in general aptitude. We will be briefly going through the formulas and then we'll be solving the previous questions. Okay, great. So we'll just wait for a couple of minutes and then we can dive into the session. I'm sure after this session, you'll be having a clear idea of all the formulas that are present in mensuration. And also you will have, or you will get an idea how to approach a question more particularly. Good evening, Murthy. Just we'll wait for a couple of minutes and then we can begin the session. You can join the Telegram link for the Biotechnica. There you will be getting regular notification and updates about all the courses, amazing things that we're doing in Biotechnica, and that will help you to reach your target, reach your goal of clearing CSIR net. This September 5th, we'll be starting the Guru batch, which is targeted for CSIR net and GATE, and that will help you to crack that exam with a good rank and fulfill your dream of going or doing PhD in some good universities. Good evening, Tej. Okay, then let's begin this session. So before moving to the question, let's briefly discuss all the formulas and the quick pointers that we need to know before we move into the mensuration and solving problems. So just before that, going to the formulas, first the triangle, the right angle triangle. So for a right angle triangle, if this is a right angle triangle, as the name suggests, the angle is 90 degrees and the area for this is given by half breadth into height. So this is my breadth, this is my height. So this is the area and the perimeter is sum of all sides. Similarly, for an equilateral triangle, the area is given by √3/4a square and the perimeter is basically the sum of all the sides, so it is 3a. For a scalene triangle, just to say that the scalene triangle is a triangle where all the sides are different. So no sides are similar, all the sides are different. So there you can use this Heron's formula, which is given by s into s minus a into s minus b into s minus c's root over, and where s is basically a plus b plus c by 2, where a, b, and c are the sides of the triangle. A, B, and C are the sides of the triangle. Similarly, for the square, the area is a square. If we consider the side of a square to be a, the area is a square, and similarly, the perimeter will be 4a, the outer boundary. Similarly, for a rectangle, the area is given by length into breadth, and the perimeter is given by 2l plus b. So I'm just quickly revising the question formula so that it will be easier for us to solve the questions. Good evening, Sanchari. Moving to other formulas, for a parallelogram, the area is given by breadth into height and the perimeter is given by 2 length into breadth. Similarly, for a rhombus, the area is given by, in terms of diagonal, it is half into both the diagonals, into the product of the diagonals. D1 and D2 are the length of the diagonals here. Similarly, perimeter is given by 4a. As we know, for a rhombus, all the sides are equal and they're parallel to each other. And for a trapezium, the perimeter is given by the summation of all the sides. This is a trapezium. So trapezium is given by the summation of all the sides, and the area of the trapezium is given by the sum of the length of the parallel sides into height upon half. So basically, this side and these two sides are parallel. If you consider it to be A and this to be B, and the height or the distance between them is h, so it is given by half into a plus b into h. Moving to a circle, For circle, the area of a circle is given by pi r square and the perimeter of a circle is given by 2 pi r. Now moving to the three-dimensional objects, for a cube, the volume of the cube is given by a cube. We know that all the sides of a cube are same. So the volume of a cube is given by a cube. Similarly, the curved surface area. Whenever I say the curved surface area, it means the walls of the object that we're speaking. So it is given by 4a square, and the total surface area will be 4a square plus the upper one and the lower one. So it is 6a square. Similarly, for a cuboid, it's length into breadth into height, and the curved surface area is twice length plus breadth into height. Similarly, the total surface area, we just need to add twice length into breadth plus breadth into height plus height into length. Similarly, for a cylinder, the volume is given by pi r square h, and the curved surface area. For a cylinder, if this is a cylinder, the curved surface area is this one, the outer one, the wall of it. So it is 2 pi r h, and the total surface area will be the curved surface area, this outer surface area, plus the upper area and the lower area. So just need to add 2 pi r square to this. As we know, the area of a square is pi r square. So if we just add it, the formula that we'll be getting is 2 pi r into h plus r. Similarly, for a cone, the volume is given by pi r square h. Now this is a cone, this is a right angled cone, this is a right angled cone. So the volume is given by 1 upon 3 pi r square h. The volume is given by 1 upon 3 pi r square h, and the curved surface area, the slanting surface area, is given by pi rl, where L is the slant height. I'll just redraw it properly. This is the cone, this is we are having, and this is L. L is the slant height. Now we know if this r is the radius, if h is the height of the cone, then using just the Pythagoras theorem, we can write L is basically root over of h square plus r square. Root over of h square plus r square. Anupam, these are very fundamental questions. These are very fundamental formulas that you keep on seeing from class 9th and 10th itself. So I don't think that once you write all the formulas once, you will see the connections between them. So I don't think that will be a lot. But yes, once you solve more and more questions, you will know which all topics we'll be discussing, what all topics to be see which are important. So you can remember those formulas only. Okay. For sphere, the volume of the sphere is given by 4 by 3 pi r cube, and the surface area, the total surface area, the curved surface area, is given by 4 pi r square. Now moving to hemisphere, what hemisphere is what? It is the half of a sphere. So hemisphere, the volume of the hemisphere will be half of the cube. So we know for a cube it is 4 pi r cube. So half of it will be 2 pi r cube. See, you can just correlate. You can remember one and try to correlate the others. That is the best thing that you can do. Similarly, the curve, we know for sphere, the curved surface area is 4 pi r square. So for a hemisphere, it will be half 2 pi r square. And the total surface area for a hemisphere, it will be cut into half. So we have a base again here. We have a base again here. So we'll be having 2 pi r square plus pi r square, which will be 3 pi r square. Similarly, for a frustum. So what is the first term? If we have a cone like this, so first term is basically a cone cut in between. So we will be having something like a bucket structure, Okay. So the volume, you can correlate this cone with the first term. So for the cone, we know the volume. For cone, we know the volume is 1 by 3 pi r square h. Similarly, here also, if you correlate, it is 1 by 3 pi h, but instead of r, you will be having this extra term, where r1 is the radius of the upper one and r2 is the radius of the lower base. You can just correlate and try to remember them. Okay. Now, similarly, the curved surface area, try to remember for the cone, it's pi rl. So accordingly, just the radius thing is changing over here. Okay. So instead of r, it is r1 plus r2. Similarly, for the total surface area, also you can do that. Now, in the total surface area, you'll be having the curved surface plus the upper one and the lower one. So that will be this pi rl plus r1 plus r2. And these are basically the upper area square of the circle, and this is this. So these are the formulas that we'll be needing. Okay. Now with this, good evening, Rigbed. So with this, let's begin with the questions. Now this is the first question that I'm posing in front of you. The surface area of a sphere is 616 centimeters square. The volume of the sphere would be how much? So there in the question, the curved surface area, the surface area of the sphere is given to you, and it is asking the volume of the sphere. Try and solving this question. So at the end of the session, you will come to know which all topics or which all objects, volume formulas or the area formulas is necessary. Okay. So if you have the surface area, in the question they have given the surface area of a sphere. So we know the surface area of a sphere is 4 pi r square. The surface area of the sphere is 4 pi r square. Now this surface area of the sphere 4 pi r square is given. It is basically 616. Basically 616. So you can just find from here r, the value of r, you can easily find it from here. So basically 4 into, you know the value of pi. Pi is 22 upon 7. So 22 upon 7 into r square is equal to 616. So you just substitute it. R square is equal to 616 into 7 upon 4 into 22. Just try solving this. So 4 ones are 4, 5, 54. So basically the value of r, you will be getting to be 7. The radius that you will be getting from here is 7. Now using this value, using this radius r, you can find the volume of the sphere. So how can you find that? We know that the volume of sphere is given by 4 by 3 pi r cube. The volume of sphere is given by 4 by 3 pi r cube. So you have now this r, the radius you know, the radius you have got. Now you just substitute this r value and find it. So the volume will be given by 4 by 3 into pi is 22 upon 7 into r cube. So r is basically 7 into 7 into 7. So this 7 will cancel out. If you multiply this term, this entire will come to be 4312 upon 3. So if you divide it, the exact answer you'll be getting to be 1437 upon 1 by 3. 1437 upon 1 by 3. I hope this is clear for everyone. So in the question, I'll just repeat what we have done in this question. So in this question, they have asked, or they have given us the surface area of the sphere they have given to us. Now, what do we know about the surface area? It is 4 pi r square. So we can just correlate these two things and find the radius. We can find the radius of the sphere from here. Now, once we know the radius of the sphere, we can use that in the volume formula and we can get the formula or value for the sphere, volume of the sphere. Great, Rigved. Now moving to the next question. Now the next question is, a copper plate of radius 3 centimeter is beaten and drawn into a wire of diameter 0.2. So the length of the wire. Try solving this question. So they have given us a copper sphere of radius 3 centimeter. Now this copper sphere is beaten or drawn into wire. Now they are asking us what is the length of the wire that can be drawn if the diameter is 0.2 centimeter. Try solving this question. Okay, so the important thing here, see, you can, at the end of the session, you will come to know which all, and regularly you will find that the questions from sphere are very frequent. Questions relating to sphere are very frequent. Sphere, cylinder, these two are the more frequently asked questions from the objects that we will be dealing. Okay, so they have said the sphere, copper sphere, it is given to us. They have given the radius. So whatever the volume of the cylinder or whatever the volume of the copper sphere will be there, that volume itself will be used for the construction of this wire. So first we need to find the volume of copper sphere. Volume of copper sphere will be 4 by 3 pi r cube. 4 by 3 pi r cube. They have given us the radius. See, 3 centimeter they have given us. So just plug in the value of 3. So it will be 4 by 3 pi RQ is 3 into 3 into 3. This is the volume. Now this volume itself will be used for drawing the wire. So the wire, if we consider a wire, it is basically cylindrical in shape. So if we consider this wire, it will be cylindrical in shape. So for the volume of the wire, we know it is pi r square h. The volume of the wire, since a wire is a cylinder, the volume of the wire will be pi r square h. Okay. Now you just need to correlate these two, because this volume will be transferred into that. So we can get this height from here, or the length from here. So 4 by 3 pi 3 into 3 into 3 is equal to pi r square. So what is the diameter they are saying? The diameter is 0.2. Diameter is 0.2. 0.2 will be halved. 0.2 upon 2 square h. So this length we need to find. Length is basically, we can say here, the height can be transformed into the length. So L. So if you solve it, pi will cancel out, 3 will cancel out, 36 upon 100. So the length will be basically, so the length that we'll be basically getting is 3600. If you solve it, you'll be getting it 3600. Now, since you can see all the values are given in meter, so you can convert it. 3600 will be converted to 36 meter. Yes. Great, Subra. Yes. Yes, Anupam. Yes. By the end of this class, you will know that what all the topics are most regularly asked. So don't worry a lot about the formulas, because once you start solving these questions, you will get an intuition of the formulas. The major problem while we are remembering the formula is we are not trying to correlate them with something. So try to pick up one formula and link others all around it. So that will be easier for you, right? Okay. So this is 36 meter. So the correct option is option D. Okay. Moving to the next question. The diameter of the base of a right circular cone is 4 centimeter and its height is 2 root 3 centimeter, the slant height of the cone. So basically, if you see a right angled cone is this. Now the slant height is basically this L. They have given us the base, the diameter of the base they have given us. The diameter of the base is 4 centimeter. The diameter of the base they have given us to be 4 centimeter. Okay. And they're saying the height is basically 2 root 3. You have to find L. You have to find L. So you can just use the Pythagoras theorem, considering to be. Great, Shubhra. Okay. Other guys, try solving this. So if you look into a right angle triangle, what you will see? H, R, if you consider this to be height, this to be radius, and this to be L. So L can be written as H square plus R square using the Pythagoras theorem. So Pythagoras theorem, if we apply here, it will be L square is equal to H square plus R square. That thing. So if you want L, that will be root over of it. Great, Diksha. Okay, so just you plug in the values. The height is given to us 2 root 3, the square of it, 2 root 3 square plus radius. We need radius, but they have given the diameter. So diameter is basically the double of the radius. So radius will be half of it. So the radius will be, since the diameter they have given 4 centimeters, so the radius will be 2. So 2 square. Now if you just multiply this, square this and add this, so it will be 4 into 3 plus 4 root over, which is basically 12 plus 4 is 16. Root 16 is basically 4. So the slant height. So the slant height for this cone is 4 centimeter. Great, Shubhra. Yes, correct. Correct. So the slant height for this cone is 4 centimeter. So the correct option is option B, 4 centimeter. Okay. Now moving to the next question. So the question, 5 congruent rectangles are drawn inside a big rectangle of perimeter 165 centimeter. So if we take this figure, the entire perimeter of this is 165 centimeter. Now it is asking what is the perimeter of one of the 5 rectangles. So basically all the rectangles present inside here are of same dimension. They are of same size. Okay. And now this, all the 5 rectangles are combined into this image. The entire image, they have been combined. The perimeter is given as 165. The question is asking what is the perimeter of a single rectangle. Try solving this question. Just wait for a couple of seconds more. So you can, if you are confused, you can take one rectangle and try to give its dimension maybe x and y, and then try to figure it out. Okay, so what we can do here, so suppose if we consider this to be a rectangle and the dimension or sides of this are x and y. Okay, the smaller side is x and the longer side is y. So we can say that this will be x, this side will be y, this will be x, this will be y, this will be y, this will be x, this will be y, this will be x, and this will be x. Why? Because we have considered, since we know all the rectangles are of same dimension, and if one smaller side is x and larger side is y, we can just see from the image and assign these things. Great, Sanchari. Great. So what is the perimeter? So perimeter is basically the entire length of the boundary. So the perimeter will be summation of all this. So basically x plus x plus x plus x plus x. So it is basically 5x plus 1, 2, 3, 4, 4y. So this 5x plus 4y will be equal to 165. That's what it is given in the question. 5x plus 4y is equal to 165. That's what it is given in the question. Great, Romy. Now, the important thing, if you can identify from this question, that you can see that this 3x is equal to the 2y. If you can see from this question itself that 3x, the length of the x is basically 3x is equal to 2y. We can see here, see this x, and this x, if we add up all, this is equivalent to 2y. So basically 3x is equal to 2y. So you can just substitute this value. So x is basically 2 by 3y. So if you can find it easily, so 5 into 2 by 3 y plus 4y is equal to 165. So in that case, just you can solve 10y plus 10y by 3 plus 4y is equal to 165. I'll just write it in the upper side, clean this up and write it in the upper side. Okay, so what we have got, perimeter is basically 5x plus 4y is equal to 165. We know. We have also seen that 2x, this we have taken as x, this we have taken as y. So 3x is equal to 2y. We have seen this. So we can just substitute y is equal to 3 upon 2x. Just this also we can do. Y is equal to 3 upon 2. So just substitute the value. So 5x plus 4, instead of y you substitute this, 3 by 2 is equal to 165. 2 2s are. So basically this is 11x is equal to 165, and you solve it, the x value will be getting to be 15. So the value of x will be getting to be 15. Great, Shubhra. Correct. So the value of x you will be getting to be 15. Now if you plug in this into the formula, 5x plus 4y is equal to 165. If you plug into this, the y value will be getting to be 22.5. You just plug in and try it. So if you plug in this formula, this value of x is equal to 15 in this formula, you will get y value to be 22.5. Now you know perimeter. So the perimeter of a rectangle, single rectangle. So we have taken the dimension to be x and y. So basically perimeter will be twice x plus y. Now if you add this twice 15 plus 22.5, it will come to be 75. Okay, 75. So the correct answer is option B, 75. Okay. I'm sure this question is clear for everyone. Okay, moving to the next question. The next question, ABCD is a triangle. ABCD is the rectangle. It is given to us, and O is the midpoint of AD. O is the midpoint of AD. P and Q are the points on A, B, and CD. See this, P and Q are the points. P and Q are the points on A, B, and CD respectively, such that they have given this dimension where AP is equal to 1/4 of AB and DQ is equal to, so this length AP is basically 1/4 of AB and DQ is basically 1/4 of DC. So they are asking basically the ratio of the rectangle, the entire rectangle ABCD to the triangle OPQ, this small triangle OPQ. Try solving this. OPQ. So try solving this. Okay, I'll just clean up this. Okay, so let's try and solve and understand this question properly. So ABCD is the rectangle, it is given to us. O is the midpoint of AD, and we know, I'll just write here important things, and we know AP is equal to 1/4 of AB and DQ is equal to 1/4 of DC. DQ is equal to 1/4 of DC. Okay, Sanchari is saying option, okay, 4A. Okay, let's try and understand this. Okay, now what we know. So if we look into this properly, we need to find the area of the triangle. So area of the triangle is basically half into base into height. Yes or no? Area of the triangle is basically half into base into height. Now, what is the base for it? This is the base. I'll just erase this thing. What is the base for this triangle? This is the base. This is the base. Now you can see, if I write base, I'll just write it here so that it's fine. So we have this image. This A, B, C, D, and these are the points. P, Q, O. This is the question that is having, and it is saying that AP is 1/4 of AB and DQ is 1/4 of DC, and it is asking the ratio of the triangle. Yes, Subra, yes. And it's asking basically the ratio of the area of the triangle with respect to the rectangle. Okay, with respect to the rectangle. So how can we solve it? So what do we know? The area of triangle OPQ is basically half into base into height. For this, the base of the triangle is PQ. Half into PQ into height. Height is basically this. So we can write this to be equal to AP. Now if you look properly, this PQ is same as BC, right? They are same. PQ is same as BC. So instead of PQ, I can write BC into AP. Okay, BC into AP. Now moving to the area of rectangle. Area of the rectangle will be basically, if we take this AB and BC, so it will be AB into BC. Okay, now what is the ratio? If we are finding the ratio of rectangle, the ratio of area of rectangle, I'll just clean this up. Area of the rectangle upon triangle. If we are doing area of rectangle upon triangle, just substitute the values. If we just substitute the values, what is the area of the rectangle? AB into BC. Now what is the area of the triangle? Half into BC into AP. But what do we know? About AP? We know AP is 1/4 of AB. So we can just write in place of AP, we can just write 1/4 1/4 of AB. Okay, 1/4 of AB. So from this BC will cancel out, AB will cancel out. So it is basically 8 times. So it is basically 8 times. Is this question clear for everyone? So basically 8 times. So you just need to write the formulas and try to divide it and find the ratio. Okay, so the correct option is option C, 8. Option C, 8. Okay, now moving to the next question. So next question is a plate of 5 meter into 2 meter size with uniform thickness. Remember, this is important. Uniform thickness. You need to keep in mind when solving this question. Weighing 20 kg is perforated with 1000 holes of 5 centimeter into 2 centimeter size. Okay. What is the weight of the plate after perforation? What is the weight of the plate after perforation? Try and solve this question. I just can give you a hint that whenever you are solving, see, it is, since it is given uniform thickness, and you can see that in this question will be perforating the holes of the same thickness itself, so you can just neglect the thickness. So instead of thinking about the volume, you can reduce the question and think in terms of the area. In terms of the area, you can think. Try solving this question. Okay, so the plate dimension, the dimension of the plate is given 5 meter into 2 meter. Dimension of the plate is given to be 5 meter into 2 meter. Now, since the thickness of the plate is uniform, and also the holes that we are considering are also of the same plate, and they are also uniform, so you can reduce the entire problem from volume to area. So in terms of area, what will be the area of it? So 5 into 10 will be 10 meter square. The area of the plate that we have is 10 meter square. Okay, 10 meter square. Now, next thing it is saying that 1000 holes are made of this dimension. Now, if 1000 holes are made, so what is basically the area? So it is asking what is the weight of the plate after perforation. So we need to find how much weight is lost due to perforation. So basically we need to find area of perforation. Area of perforation, basically total area, I must say total area of perforation, it is basically 1000, because 1000 holes are being made, into 5 upon 100. Just I'm converting this to meter, since we have the area of the plate in meter. 5 upon 100 into 2 upon 100, I'm converting this to be meter also. So if you solve it, it will be 1 meter square. It will be 1 meter square. So we have the area of the plate, to be 10 meter square. Total area of perforation, to be 1 meter square. So what is the weight, or what is the area that is left after perforation? So area left is basically 10 minus 1. Basically 10 minus 1, which is 9 meter square. So this is the area that is left after perforation, which is 9 meter square. Now we know that when the area of the plate was equal to 10 meter square, the weight of the plate was 20 kg. We can just use unitary method for it. Great, Shubhra. Great, Murthy. Correct. So for 10 meters square, when the area of the entire plate was 10 meters square, the weight of the plate was 20 kg. Now, if the area of the plate is reduced to 9 meters square, now it is reduced to 9 meters square. So you can just use the unitary method. So it will be 20 upon 10 into 9. 20 upon 10 into 9. So it will be 18 kg. It will be 18 kg. Correct, Romy. Option D, 18. Okay. So it will be option D, 18 kg. Okay. Moving to the next question. Okay. A rectangle is given ABCD, and it is saying that AE is equal to EF is equal to FB. Now, what is the ratio of this area of the triangle EFC? So this area, the ratio of area of this triangle EFC with respect to the rectangle ABCD. So basically we have to compare this area this area of the small triangle EFC with respect to the entire rectangle ABCD. Try solving this question. I'll give you one hint. You can draw or you can construct one line, this. So that will be helpful for you to calculate the area of the rectangle. You can make a extra construction over here. Okay, let's try and understand it, how to solve it. Okay, now it is given to us AE is equal to EF is equal to FB. Now what is the question? It is asking us the ratio of area of the triangle EFC with respect to the rectangle ABCD. Now let's find the area of the rectangle. So the area of ABCD, rectangle ABCD, area of the rectangle ABCD, if you look properly, if you consider this line, then you can say this is basically twice into area of triangle ABC. If we make this construction, if we join the diagonal AC, we can say that the area of the rectangle ABCD is basically the double of the area of the triangle ABC. Okay, double of the area of the triangle ABC. So twice into, what is the area of triangle ABC? This is basically half into base is AB into height is BC. So half and half, this will cancel out. So it is basically AB into BC. This is basically AB into BC. Okay, this is basically AB into BC. Now coming to the area of the triangle, area of triangle EFC, area of triangle EFC. If you look properly, the area of triangle EFC, you can see that this area of the triangle will be given by half into base into height. Half into, what is the base? Here base is EF. Here base is EF. Here base is EF. Into, what is the height? Height is same. The height is BC. Height is BC. Just you can write this. So the ratio. So if we write here the ratio of the triangle. So if you write here the ratio of the triangle, so just we'll plug in this value, half into EF into BC upon AB into BC. Now you can see BC will cancel out. So I'll just writing up. So it will be half into EF upon AB. But if you see properly in the question itself, it is given that AE is equal to EF is equal to FB. So we can say AB is equal to thrice of EF. You can see because three parts are being made, thrice of EF. AB is equal to thrice of EF. So we can just plug in this value. 1 by 2 into EF upon AB. So AB is basically thrice of EF. So it will be 3 EF. EF will cancel out. So it will be 1 upon 6. Correct, Shubhra? Great. 1 upon 6. Murthy can solve it completely. So basically it is 1 upon 6. Okay. Just you need to properly see, in case of area of a triangle, you need to properly find out or identify basically what is the height and the base. Okay. Moving to the next question. Same. What is the perimeter of the given figure where the adjacent sides are right angle to each other? This is a very simple question, but a good one. So basically you have to find the perimeter, the entire perimeter of this diagram. Try solving this question. You just wait for a couple of seconds more. Okay, so let's try and understand this. If you see this diagram properly, this diagram, I'll just redraw it properly. Maybe I'll redraw it again. So you can see it from here itself. We can see it from here itself. So if you draw this, if you extend this entire thing, the same thing, if you extend this will be basically a square, you can see, because this same length is here 5 centimeter. No matter how much up, you need to calculate the entire perimeter. So if you observe properly, if you bring this line down, to this place, this will complete this thing. Similarly, if you bring it here and bring it there, so basically what is that? If you observe it properly, each side length, if you add this also, each side length will be 5 5 5. If you add all the sides, it will be 5 plus 5 plus 5 plus 5. So basically it will be 20 centimeter. Great, Rumi. So you just need to observe properly this question. Just need to consider that if this walls would be the back, and then how much it will be. Okay, how much it will be. So the correct answer is option A, 20 centimeter. Moving to the next question. So 4 small squares of side X are cut off a square of side 12 centimeter to make a trap by folding the edges. What is the value of X so that the tray has the maximum volume? So I'll give you an example and make you understand. So if you have a tray like this, it is saying 4 small squares of side X are cut from the edges for folding. So if you have a tray like this, if you want to fold it, then you have to cut from the edges. Maybe I'll draw a bigger one just for reference. If this is a square tray you are having, if you are having this tray, now it is said to fold. So how can you do it? So you have to cut the edges. So basically you have to remove this square, this and this area. You have to remove this area. So basically you will be getting something of this short, because you have removed 4 corners square so that they can be folded. Now you can fold them. Okay, now basically you can fold them. So it is saying 4 small squares of side X are cut from a side of entire tray of 12 centimeter. What value of X should be cut so that the volume of the tray is maximum? Okay, volume of the tray is maximum. Try solving this question. Okay, let's try and understand this. So we have 4 small squares of side X. Now if you have a square of side X, so this is X, 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 this is X. So each side of the square, initially if the side of the square was 12 centimeter, now since we have cut 2 squares from the corner, so basically each side length would be reduced to 12 minus X. Yes or no? This square, the entire square, the dimension of each side will be reduced to 12 minus 2X. Because from left side also X we have cut, from the right side also we have cut. Great, Polish. Great. So the dimension of the square, the side of the square is reduced to 12 minus 2X. Okay, 12 minus 2X. Now you can see that if we are folding the tray with X, so basically the height will be X. The height will be X for it, because we have cut the edges of side X. So when we are folding it, the height will be X. So if you want to calculate the volume, I'll remove all this. So volume, so basically you will be getting some kind of cuboid with the upper is empty. Okay, so the volume of the cuboid will be basically 12 minus 2X. So basically the length and breadth are this 12 minus 2X into the X, because X is my height. So basically the volume of cuboid is length into breadth into height. Okay, Now we have this length and breadth. This is, since the base is a square, length and breadth, so it is reduced to 12 minus 2x. So it will be 12 minus 2x square into the height. Height is x. Now you can just plug in the values of x from here and find for what case you will be getting the maximum volume. So if you plug in the value of 6, if you plug in the value of the 6, if you plug in the value of the 6, the volume that you will be getting will be basically 0, because 2 into 6 will be 12, 12 minus 12, 0, so the volume will be 0. So if we're plugging the value of 2, if you are plugging the value of 2, so 2 to the 4, 8. So it is basically 64 into 2, 128. The volume will be getting. So basically, if you are plugging the values, so basically you have to plug in the values and check it. Okay. Now if you are plugging the value of 2 here, 2 to the 4, so basically 8. 8 square is 64. 64 into 2 is 128. So if you are plugging the value, it's 128. Similarly, if you plug the value of 3, so it will be 6. 6 square 36. 36 into 3 is 108. 108. Similarly, if you just plug in the values for 4, if you plug in the value for 4, it will be 4 square is 64 into 2. I'll just remove this. So if you plug in the value of 4, if you plug in the value of 4, 4 to the 8. So basically just you have to substitute it. 4 to the 8, 4 square is 16. 16 into 2 is 32. So basically for 2, if you check all the options, it will be 2. Great, Sanchari. Yes, the option is 2. So if you plug in the value of x, so if the dimension of the square is 2 centimeter by 2 centimeter, we'll be getting the maximum volume. Okay. So the correct option is option B, 2 centimeter. Moving to the next question. Okay. It's saying that a 2.2 meter wide rectangular steel plate is corrugated. Corrugated means if you have a flat edged this side, if you have a rectangular plate of this size, corrugated means the sides are made in a wavy pattern. So basically now the sides are curved, are made into form of waves. So a 2.2 meter wide rectangular steel plate is corrugated as shown in the figure. You can see here, each corrugation is basically a semicircle. So now initially it was a flat surface. Now we have made a curve out of it, small curves. Okay. So it's a semicircle in cross section having a diameter of 7 centimeter. So what will be the width of the steel after it is corrugated? This is a good question. What will be the width of the steel after it is corrugated? So of course you can see that if we have an entire plate here, if it is corrugating, so we'll be forming semicircles. So the width of the plate, with corrugation will be reduced. So that width we have to find. Try solving this. Okay, let's understand this. So basically the length or the width is given us to be 2.2 meter. So just I'll convert to centimeter for our convenience. So 220 centimeter. 220 centimeter. Now this width will be equal to all the corrugation that we'll be making, all the wavy patterns we'll be making, and the patterns will be in wave nature, or they will be basically semicircles. They will be basically semicircles. So to draw it properly, what we'll be getting basically is a structure like this. We have made waves or semicircles like this. So basically this width will be reduced. Okay. Now if we consider this width, the radius or the diameter they have given to be 7 centimeter. So we know that we know what is the circumference, or we can say the perimeter. The perimeter for a semicircle is basically pi r. For a circle it's 2 pi r. For a circle it's 2 pi r. For this it is pi r. Now we will be having x. Let's consider that we'll be having x convolutions or corrugation. So it is basically x into pi into r. R is 7 upon 2. R is 7 upon 2. So we can just solve it out. 220 is equal to x into pi is 22 upon 7 into 7 by 2. So 2 22, 22 will be 10, 7, 7 will cancel out. So basically x will be 20. So basically we'll be having here, will be basically the semicircles, the number of semicircles in a particular width are 20. The number of semicircles in a particular width are 20. Now we know that now we know that the number of corrugations that we are having is 20. This is number of corrugations is 20. And we know for each corrugation, the diameter is basically 7, or for each semicircle that we are getting, the diameter is 7 centimeter. So what we can find it from here? So for one corrugation or one semicircle, the diameter, because we are calculating the entire length, so for one it is 7 centimeter. For 20 it will be 7 into 20, so it is basically 140 centimeter, which is equal to 1.4 meter. So the correct answer is option A, 1.4. Now because of this semicircle, now you can see that initially it was flat, but we folded it, in this manner. So effective width will be this much only. Effective width is this much only. So we just need to add the diameter, the total diameters from starting point to end point of this total semicircles. Great, Shubhra and Murthy. Yes, you have got it correct. The option A is correct, 1.4 meter. Okay. Moving to the next question. Two coconuts having spherical space inside their kernels, with the first having the inner diameter twice that of other. The other one is half filled with liquid, while the smaller one is completely filled. Which of the following statements are correct? So basically in this question, we are having two coconuts. We'll be having two coconuts, one larger one and a smaller one. Now for the larger one, let's consider that the radius is capital R, and for the smaller one the inside radius is small r. Now it is saying, in the question itself it is saying that if you compare, the inner diameter of the first one is twice of that the other, so let the bigger diameter is R. We can say, since we will be comparing with respect to radius, so we can say that the radius of the bigger one will be twice radius of the smaller one, because of the first statement it is given to us. The larger one is half filled. So if we need to compare the volumes, basically we need to compare the volume basically. So the volume, we know the volume is 4 by 3 pi rq. Volume is 4 by 3 pi rq. I'll just write it over here. So we have this is the bigger one with capital R. This is the smaller one with small r, and we know capital R is equal to twice. In the question it is given to us, in the question itself it is given to us. Okay, now for the formula for volume, see how many times we have discussed the formula for sphere. So it is a very important concept, the volume formula for the sphere, for the area of the triangle and all. So it is important. So volume is 4 by 3 pi rq. Volume is 4 by 3 pi rq. So you can just substitute it. For the larger it will be, for the larger the volume is 4 by 3 pi rq. But in the question it is said that the larger one is half filled. So basically it is half filled. So it is 1 upon 2 4 by 3 pi rq. So this is capital R. Since we are considering this is capital R. Okay. Now we know this capital R is twice of the small r. So just substitute here, 1 upon 2 into 4 by 3 pi r upon, so I'll just remove it. So capital R is basically 2r, we can just square it. So basically we'll be getting 4. From this 4, 2 will be cancelled. So it is basically 2. I'll just write it over here, twice into, I'll just write it, erase it over here. Pi rq, we have to cube it, pi rq. The formula is 4 by 3 pi rq. Okay, pi rq. So just substitute it here. So basically we'll be getting 4 into 4 by 3 pi rq. So this is the volume of the coconut, larger coconut, which is half filled. Now the volume of the smaller coconut, is basically 4 by 3 pi rq. Now if you compare the ratio of the volume of the larger, which is half filled, upon the volume which is smaller one, which is completely filled, it is 4 into 4 by 3 pi r cube upon 4 by 3 pi r cube. So basically 4 times. So basically 4 times it is there. So the volume or the liquid present in the larger coconut is 4 times the smaller coconut. Okay, smaller 4 times the smaller coconut. Let's try and see the options. So the first option is saying the larger coconut contains 4 times the liquid in the smaller content. This is correct, 4 times. So this is how we solve it. Okay. Great, Shubhra. Sanchari, you can check your calculation. I think you might have missed. Yes, correct, correct. It's 4. Okay. Okay. Moving to the next question. The area of the 3 parts of a rectangle are given in unit centimeter square. So what is the total area of the rectangle? If this is the rectangle and this area, the area of this portion is 3, it is given. The area of this portion is 6, it is given. And the area of portion is 9. So you have to find the area of the total rectangle. So for that, first you have to find the area of this place. Okay, okay, great, fine. For that, you have to find the area of this place. This area first. Try and solving this question. Now let's try and understand. We can do this through a normal procedure, but also we can solve it through intuition also. So let's first do through the normal procedure. Okay. Now consider this to be a rectangle. So let this side be A. Let this side be A. This side be B. Similarly, this is a rectangle. Consider this side X. This is Y. Similarly, for 9 also you consider. I'll just remove it here. Since this is A, so this side will be also A. The same, it is right. Same here. If this is B, this side will be B, and this you can consider Y. Okay, this side you can consider Y. Now the area of this place, is basically area of this one, area of the shaded portion where the one I have shaded is basically Y. This basically this is we have taken to be Y, and this we have taken to be X. See, X. So basically it is X into Y. But what we can infer from the others, so if you look into the first triangle, 3 is the area, and the dimension of this we have taken A into B. Similarly, if you look into the other triangle, 6, the area of the rectangle 6. Now if the dimension you see X into A. Similarly, the other rectangle 9, if you see the dimensions we have taken to be Y into B. So from here we can write X is equal to 6 by A, and similarly Y is equal to 9 by B. So if you just substitute here, X is basically 6 by A into Y is basically 9 by B. Great, Sanchari saying 18. Okay. So A by B, 9 by B. So basically it is 9, 6 are 54 into AB. Now we know this AB is 3. So it is 54 upon 3 is basically 3 ones are 3, 18. This area is 18. Okay, this area is 18. But we have to find this area we have found out to be 18. Okay, but we have to find the total area. We have to find the total area of the rectangle. So just add this all. So the total area of the rectangle will be 18 plus 6 plus 3 plus 9. So it will be equal to 36. This will be equal to 36. Okay. Sanjay, I think you mentioned we need to find the total area of the rectangle. Okay. So the total area of the rectangle will be 36. So the option C is correct. Now there is another simpler way to solve it. With intuition only you can solve this. Let's try and see this. Now you can see that if you compare this triangle and this triangle, this side and this side are same. This side and this side are same. So if the area of this triangle is 3, rectangle is 3, and this is 6, so basically we can say this side length is double. We can say this side length is double because this side and this side are same. So the only changing factor is this side. So basically we can say this is double. So we can divide this. Since it is double, we can divide it. So it will be unit of 3. Okay. Similarly, if you compare this and this, you can see that this is 3. Okay. Now this, the both the rectangles have this side same, so the only variation is due to the top edge, the flat one. Okay, so we can say that it need to be 3 times of it. So we can just break it into 3 parts. Okay, break it into 3 parts. Now we can see here we have, now we can see here we have a box of this many spaces. So we know for a single space it is 3. So just you can add 1, 2, 3, 4. 4 into 3 is 12. So we have 12 spaces, and each box is 3. The area is 3 units. So basically it will be 36. Through intuition also you can solve it. Yes, through intuition also you can solve it. So this, in exam you should try through intuition method, it will be easier. So just try to see and break it. Okay, try to see and break it. Okay, let's move to the next question. Okay, so a mineral containing a cube and a spherical cavity, the length of the side of a cube is the same as the diameter of the sphere. So if the cubic cavity is half filled with the liquid and the spherical cavity is completely filled with liquid, what is approximately the ratio of the volume of liquid in the cubic cavity to the spherical cavity? This is the question it is asking. So basically what we have a cube, we have a cube over here, and we have a spherical cavity. Okay, now the next thing it is saying that the length of the side of a cube is same. Let's consider the length of the side to be a, is same as the diameter, is same as the diameter of it. So the radius will be a by 2. For the radius of the sphere will be a by 2 for it. Okay, radius of the sphere will be a by 2. Now it is saying that if the cubic cavity is half filled, so the volume of a cube is a cube. Okay, sure, Tej, we'll do it. We'll do it. Just let's complete this question and then we'll move back to that question again. Okay. So the volume of the cube is basically a cube. The volume of the cube is basically a cube, but it is given the question that we need to half. So basically the cube is half filled. Okay. So the volume of liquid in the cube will be basically a cube by 2. Will be basically a cube by 2. Okay. Similarly, if you look for the sphere, if we look for the sphere, so I'll just erase it, whatever we have got it. So volume of cube which is half filled, we have got to be a cube by 2. We have got this to be a cube by 2. Similarly, but the sphere, what is the radius of the sphere? We have known it is a by 2, because in the question it is given that the side of the cube is equal to the diameter of the sphere. So it is, radius is basically a by 2. So the volume is basically 4 by 3 pi rq. In place of r you can put a by 2 q. So it will be 4 by 3 into pi into a cube upon 8. So basically it will cancel out. So it is basically 1 upon 6 pi a cube. 1 upon 6 pi a cube. Okay, this is the volume that for the sphere will be having. Now we need to find the ratio. So what is the ratio? We need to find the ratio of volume of the liquid in the cube to the cavity, to the spherical cavity that we have. So volume of the cube is a cube by 2 here. It's a cube by 2 upon, this is what we have from here. This is what we have from here. So it is 1 by 6 pi a cube. 1 by 6 pi a cube. So a cube will cancel out. So basically up we are having 1 upon 2. Here we are having 1 upon 6 pi. So basically 1 upon 2 and 1 upon 6 will cancel out. We'll be getting 1 upon 3. I'll just erase it here. So basically will be, if we solve this, is it visible? Yes. If we solve this, it will be 1 upon 3 pi. So we know what is pi. So it will be basically 3 into 7 by 22. This is what we'll be getting, 3 into 7 by 22. Now 3 into 7 is basically 21. Is basically, I'll just write it here, is basically 21 by 22. So we can say approximately it is 1:1. We can say approximately it is 1:1. Okay. Shubhra, I think you have missed something. You can just maybe I'll repeat what we have done in this question. Okay, so we have a cube here. In the question it is said, if you follow the question properly, the length of the side of the cube is same as that the diameter of the sphere. So if you consider the length of the side of the cube to be a, the radius for the sphere will be a by 2. That the next thing is you need to find. The next thing you need to find is the volume. So for the sphere, for the cube, we'll be getting a cube. But in the question, it is given that it is half filled. See, half filled with liquid. It is half filled with liquid. So basically, it is a cube by 2. Similarly, you need to find the radius. Sorry, the volume of the sphere. Just plug in into the formulas. I think you might have done some calculation errors. Okay. 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 Moving to Tej, you asked about that coconut question. Okay, yes. So Tej, you were asking about the coconut problem. Just we'll move quickly to the coconut question here. Okay, so according to the question, we are having two coconuts, one a bigger one and a smaller one. And it is saying that inside the coconut, both are spherical in size, dimension. So the first coconut is having an inner diameter twice of that other. So if this is a larger one, this is a smaller one. Let's consider this radius to be capital R, this radius to be small r, this radius to be smaller. So we can say that if the diameter is twice, we can say the radius will be also that. So the radius of the bigger one will be capital R, which is twice of the smaller one. Now the next thing is, it is saying that the larger one is half filled. I think you are missing that point. The larger coconut is half filled. So you just need to consider when you are writing the formula for the volume. So volume basically is 4 by 3 pi r cube. So just substitute here, but you need to remember that the volume that we need to fill, it is half. Okay, I think that you are confused in that. So you need to put in half and solve it. Okay. Okay then. So with this, in this session, we have briefly discussed about the formulas that are very important for mensuration, and we have seen some previous year questions. I'm sure after this, you at least know how to approach questions when you are seeing regarding mensuration. I'm sure this session might have helped you a lot in enhancing your knowledge in mensuration. So please subscribe to the Telegram channel of Biotechnica. We'll be providing much more updates into it, and you can subscribe to the channel of Rasayanika and Biotechnica also for more such entertaining knowledge-based topics in chemistry and biological sciences. Thank you all for remaining with me. Thank you.